Hey guys, welcome to this another episode on Angular Casts. I'm Ashish Singh and you're watching Typescript series on Angular Casts. So let's get started. In this series, in this particular episode, I'm going to cover TypeScript functions. Actually, I'll be covering these 6 points in detail about TypeScript functions. Let's see what all we're going to cover. So first of all, we'll go in detail about how you can declare a function, and then we'll move on to discuss. We'll discuss how code is generated into JavaScript once you write a TypeScript code. Then we'll look at how the code and the parameters actually are destructured. So actually I'll go in detail when I'm covering that point. After that we'll look how function overloading works in TypeScript, which doesn't actually work in JavaScript out of the box. Then we'll also look at how you can what has TypeScript fixed in terms of context switching, and how you can write nested functions. After that, yeah, so that's all. So that's pretty much I'll be covering in this tutorial. Let's get started. So how you can what are functions in TypeScript? Functions in TypeScript are no different from what functions are in JavaScript. So TypeScript has added a little more support, or you can say type checking, or functionality into functions. So you define a function the way you define in JavaScript, but with a few little modifications, and which of course give you more power and better code. So let's say I want to define a function called add, and since it's a function which is adding something, so let's say I want to add two numbers. Let's say a and b. I want to add a and b. This is what I'll do in JavaScript, and this will work fine. So let's do it. Let's try to call this by passing it two numbers. Okay. Now as this okay, let me just show you guys my setup here. I have this function.ts file, which is of course in TypeScript. I'm writing this in TypeScript, and since TypeScript supports, or you can say it's a superset of JavaScript will work just fine in this .ts file. So it doesn't matter what I'm writing in this file, unless it's JavaScript or TypeScript, it'll just work fine. Okay, so on my left I have a function.ts file which has all my TypeScript code. On the right I have my out.js. So this out.js is a file which my code from my function.ts file is being compiled on runtime into out.js file. So that means when I save this file, I'll get a JavaScript converted code, or compile, or you can say compiled code of this file, or of the file on the left. So this way we can just compare what our TypeScript code is being compiled to, just to be aware of what's happening under the hood, what extra power TypeScript is giving us. So as you can see, it was simple plain JavaScript. It doesn't do anything. It doesn't do anything with it. It's compiled to the same code. Now what TypeScript adds to this is we can actually tell the TypeScript compiler, that I want this a variable to be of type number, just because see the basic idea in TypeScript is type checking. The only reason, I won't say the only reason, but the very important and prime reason Microsoft started working on this new language 3 years back was this, that they wanted to actually add this type checking feature into JavaScript. So let's say, yeah, so I have told my compiler that this add function accepts a parameter a, which is going to be of type number. Okay, cool. And let's try and save this. When I save this, and nothing actually happens on my right. So the compiled code, which is in JavaScript, does not show any change. I'll come back to that later. Let me first show you what all I can do with this. So I can say that this function, this another parameter which is which is b parameter here, this is also of type number. So when I try to give, let's say I have, so you must be wondering what's the benefit of this. So the clear benefit is I can't pass it a string. So if I pass, let's say, a string, you see that red squiggly down there. So if you go to the bottom of this page, in you can see the argument of type string is not assignable to parameter of type number, which means that you cannot pass the second parameter as a type string, which is this, to to a number which was expected actually. So to fix this, we can simply change this to string and it will fix it. Cool. Okay, so now we understand that our functions can be more strict about what kind of parameters they take in. So that's the kind of features we have it. One more feature here is that people coming from strictly typed languages will actually acknowledge this, that you can, in TypeScript you can also assign what is the return type of this function. Let's say, since it's it's an add method, I number would be just fine, so I assign it of type number, and I expect this to be of type number. Let's see, I think I see, okay, so type string is not assignable to type number, that's what. So actually we'll go ahead and fix this error. So meanwhile, let's just fix that. Okay, so this is a temporary hack for me. Since I said I'm expecting a number to be the return type of this method add, so I had to put that just to fix that error temporarily. So a function name, then followed by its parameters, and then a colon and the type. So this type will be the return type of this function. Okay, cool. Now we understand how functions are actually working in this. There's one more thing I'd like to I like to tell you guys at this point is, let's say I'm writing plain JavaScript and I'm not assigning it any type. Let's say I do this. Let's say I get rid of these two types. Now what happens is now you can see I can pass anything. So I have my first parameter is a number, is of type number. My second parameter is of type string. So what's happening here? So the thing is, when you do not assign a type in TypeScript, by default it will take the type as any. I have discussed type in my previous video, so if you have any confusions regarding types in TypeScript, just head over to my previous video. I'll also be adding the link in the description below, so you can check out more about types. So I want to tell you a little about type any. So any can be of type any, as the name suggests. It can be a number, it can be a string or anything, or a boolean or anything. We can be of any type, so that works just fine. So let's get our types back. Okay, now it should be of, let's say I want a string. Cool. Okay, now so that's the basic idea of functions, the parameters, then assigning them types and the return type, and how you can call them. Okay, so now moving ahead, you can also actually define the default values in functions. Let's say I have this number, and actually I don't want b to be string. Actually I want b to be, let's say I want to assign a default value to b. Let's say I want to assign b a value of let's say 5 greater than my what's the value of a. So I can do something like this. Now what's interesting here to note is that I have this first variable called a, or a parameter I'd say, and my second parameter is b. So if I have this number, this assigned as number, and this b, so if I try to add something other than a number here, it won't work. It'll give us a compile time error. So that's the basic idea. And one other thing is that, let's say if I have a third variable called c, so it's not that I can say, let's say I have c, default value of c is assigned to 4. It cannot do this actually, because it'll give me an error. So the error I'll get is that this c is initialized a value after of b, so you cannot use the c before of before even initializing it. So that's the error. I just wanted to give you an idea of how this works. So I was telling you guys. Now here it's very easy to use a plus b, because a and b have already been initialized, so you can actually access them here. Okay. So that's how it works. Now I think it's a good time to actually look at the JavaScript code, which is pretty interesting now. So as you can see, I'm passing 3 parameters here, and now the interesting part starts here. If b is actually not defined, or you don't pass a value for b, what it'll do is it'll actually do that. So it'll actually initialize a value of a plus 5, which is 5 greater than a, to b. So if you don't pass a value, so let's say you're trying to call this method with this, so it'll work just fine. See, you don't get any errors. So the reason for that is because in this function, it'll try to see if, so this condition is will be valid, and b will be assigned 5 more than a actually here. Similarly, we haven't provided c here when we're calling this method, so this condition is valid, and my c will be the value which is a plus b. So this is how default values can be assigned to the parameters. So it's actually very interesting to see how TypeScript is taking care of a lot of things which we used to do manually in our plain JavaScript code. Okay, so that's all. So next thing I want to cover is that sums up function declaration and how you can use a function. Now let's head over to how code is generated. Exactly this thing, how code is actually generated in TypeScript. So for the sake of simplicity, I'll go ahead and copy some code which I've already written, and get rid of all the comments. Okay, and oops, yep, yeah. So the way it works is, see, this is the function name, these are the function parameters. So the very first thing which will happen in a TypeScript function is default value assignments. By this we mean that that all the default values will be assigned to the parameters. Now after that only some sort of whichever logic you have inside your function will be executed. So let's see that for example. Let's say I have a function which says a is a number, and then b is a string, and then let's say not a string but a plus 5, or let's say 10, and then let's give it a name. You say subtract, and so let's say I have this function, and it has some logic. Let's say return a minus b, yeah. So the things that will happen is, first it will go and assign values to the parameters, and then it will put in all the logic part of the function. Okay, so that is I just wanted to cover how code generation works in TypeScript. So yeah, so we've covered default parameters, we've covered code generation, and yeah, one more thing I wanted to cover here is destructuring parameter declaration. So one more thing I want to cover here is actually optional parameters. So let's have okay, so I don't want you to see me code a lot of stuff, so I've written some code down for you guys, and let me just paste it here. Yep, and just get rid of the comments. Actually, I'll be covering interfaces in coming lessons, so I won't be covering interfaces in detail in this particular video, but do check my videos in future and subscribe to my channel so that you don't miss out on anything in TypeScript and of course in AngularJS. Yeah, so what in short what interface does is it'll define an interface or some set of rules which can be used somewhere else. You can define optional parameters by putting this question mark in front of the variable or the property, you can say. Um, so that way TypeScript compiler will know that this particular variable is optional. It can be, if you don't provide it, it's fine. Otherwise, if you provide it, it's good. So in this particular example, what I'm doing is I have this call superhero method takes in an object which has these properties, name, location, and it has this variable called active. This is of type bool. So superheroes have a name, they have the location, the current location, and if they're active or not at the moment. So when I'm defining this function, let's say Mr. Iron Man is the most dependable. If no one is available, I want Mr. Iron Man to be there, and he'll be there to save us, save our planet as always. And his location is the ground zero. He's always present at the ground zero, and he's always active. So what I'm trying to imply here is that uh, these values are the default parameters. So if you do not, if there's no superhero available, or in technical language, if you do not have this name property in the object which you're using to call this superhero method, then these values, this Iron Man, the location 00, and active set to true, will be passed to actually this function. And I'm expecting this return type of this function to be string, which actually doesn't matter in this example. So what happens is, let's say I call this method by the name empty object. So what will happen? Let's try to find out. Okay, so this is the empty object, and it's a function call. Cool. Now let's say we have name. Okay, and then name, we have this name. So let's see if my default values of Iron Man actually show up in my code. Yeah, so the name is Iron Man. So that's how we know that this actually worked. And if I do not provide in any values, default values are taken. Actually, at this point of time, I'd like to show you guys how actually this thing is working. So actually this thing is called Destructuring of Parameter Declarations. So the way it's happening is, since I have my attributes, or you can say properties, as optional, so this is how TypeScript will handle this for us. Let me just break this down into smaller bits of pieces so that you can actually understand what's happening in the background. So this is the compiled JavaScript. Let's just try and break down this. The object that I pass to this function is an empty object, which is assigned to this underscore a variable here. Now our converted type JavaScript says that if is trying to assign the name property on my call object to underscore b variable. Okay, let's just go ahead with that. Now after that, it's trying to check if my underscore b variable is not present. If it's not present, then it's assigning the name Iron Man to this name variable, which makes sense because we wanted our name variable to be assigned Ironman, which was our default parameter, and this is exactly what's happening here with just simple JavaScript code. If not, if actually this condition is false, which means b is present, then underscore b is assigned to the name object, which is, and underscore b is underscore a dot name, so which makes sense. So nothing happens, nothing magical happens, and your default value is overridden. Similarly, our underscore c variable is assigned the value of locations. So let's say I happen to call this call superhero method with an empty object. This will again be not present and undefined, so my underscore c would be undefined. This condition is true, then my default values will be assigned to variable underscore d. And if not, let's say if I passed an array with the values, with the coordinates of my super usual values will be assigned to d, and then they'll be further classified into x and y based on the first and the second value. Similarly, it happens to the variable active, or let's say parameter active. Active property is assigned to underscore e object. It's not present, then you assign a value of true, which is our default value. If not, if it is present, then you go ahead with whatever came in, and you get the real values, and you do not override the values. So this is called destructuring parameter declarations. This is how TypeScript handles it, and it's pretty cool how much code they actually write for us. Yeah. So that was it. Now the next part I want to cover here is function overloading. So by default you do not have function overloading in JavaScript. You do have it in TypeScript, so let's just try and find out how this works. For the sake of simplicity, I'll again have to copy a lot of code. Cool. So I don't want you to see these. Yeah, so let's say I have this function called calculate area. So the way I do it in TypeScript is I'd create a function called calculate area, and then I'd say length breadth, but since I know that my length is always going to be an integer, so I'll give it a value of number, and then I'll go ahead and do my custom logic in here, and then I'll return something. Let's not return anything because I haven't specified any return type, which in case is going to be any, and it'll work just fine. So let's say I have this, and let's say my code requirement is such that you do not know what kind of parameters are gonna be coming into this calculate area method. They can be of, so let's say my length can be of type any, or let's say, actually my length can be of type string as well. So people do not remember, and people do not know, they're not smart enough, and they end up calling my calculate area method like this. So what will happen is this will give me an error because my breadth parameter is actually of type number, but I'm providing it a string of type string. So this will actually not work for me here. So the obvious solution to this problem is function overloading, what we call as function overloading. In this I can actually define multiple declarations, and then one definition to actually adapt to all those multiple declarations. So let me give you an example. Yep, I have all these declarations, multiple declarations, I would say. These are declarations wherein I have calculate area, and I say length can be a string with a number, or number pair, or number string pair, or string pair, but they all return this common return type, which is number, which makes sense actually, because what you expect out of a calculate area method is a number and not a string, irrespective of what goes into that function. So the fact that we're writing these four declarations is that we want to adapt to what user enters the function. So but an important catch here is that since we are saying that length is of type string, length can be of type number, so there are multiple ambiguous what do you call types to this same parameter length. So for that we will get rid of any kind of types in this part. So actually it becomes what do you call an any type, and breadth is also now is of type any. So that way you can put your custom validations and logic inside of the function, and you can just return after that. Here I've simply converted my strings, if strings, to an integer, and then I do a multiplication on that, which works fine. So when I say when I call this method calculate area with a string, it works, it doesn't break. One may argue that this will work just fine if I do not put in all these declarations. You are right there, but because since these are of type any, and it can be a string, it can be a number, so this would work. But let's just try and call this method without my function declarations. So let's say I'm going to call this method calculate area. Now this gives me okay, right, okay, yeah. So the thing is, it gives me examples, it gives me a prompt that calculate area is expecting two parameters. One is of type length, another is of type, so one is length, another is breadth, and they are both of type any. So this way we are not sure of what's going into the function. It is any, it can be a bool, length can be a bool. So if you pass in a bool, it won't break, it will just compile fine, which can add a lot of ambiguity. So if I say true, and let's say true again, true and false. So I'm someone who doesn't understand the code. Let's say I'm exposing an API, APIs, and I'm writing some library, and I have exposed a function. So I don't know what's actually going into that function, and by mistake I pass in these values which were not expected inside of the function. So in this function I'm expecting strings and integers, so anything apart from that will actually end up breaking my code. I don't want that. So what I do is I define these declarations. Now my TypeScript compiler knows that I have these four declarations in place, and I'm expecting these pairs when I'm calling this function. So after this, after writing these declarations, when you go and call this, it says that it has four overrides. You'll have to click on that to find out. When you click on that, you see calculate area is there are four different declarations with which you can call overloads, and these are the types of the parameters which we can pass to this function. And we exactly see that it's of return type. This function's return type is number. So it's actually useful when you're trying to expose an API, especially when you're writing a library in TypeScript, and this actually helps a lot. So when I click on that, I get access to the overload I actually wanted to use. So let's say I wanted to use the third overload. I can do this. I can do this, and my code will work fine. So actually using overloading is in a very you can say nice way is so actually using actually it facilitates us. Got it. Yeah, now start from here after the beep sound. Beep. Using defining a lot of declarations actually gives us or the programmer the power to understand what the function is expecting, and actually helps in writing better code. So let's just try and save it. You can see there's nothing much happening in our JavaScript code. It's simple our calculate area function as we write it in JavaScript. So what actually happened here? uh, TypeScript understood what overload is. It actually used overloads to give us suggestions, but the thing is, overloading is totally a compile time construct. It's not what compile by compile time construct. I mean, when you're compiling TypeScript, then it'll do its magic under the hood, and then it'll convert it to the code. So you will get errors at the compile time. So let's say if I pass in values like true, I may get an error. I will actually get an error at the compile time. With the code that's converted into JavaScript, it's not dependent on this TypeScript code. So this type checking, so when you're coding in TypeScript, you actually get this error. You rectify that error by writing better, more responsible code, and you end up saving a lot of your time. So that is actually what's interesting in TypeScript. Yeah. Okay, so that was all about function overloads. The next topic I want to cover in functions is function shorthand notation. So let's see what it is. So in TypeScript, you can actually define a function using this very cool syntax, where you can say x is actually, just let me give you a short demo. Cool, let's just save it. Yep, as you can see, uh, when I use these round brackets to enclose my x, and then this fat arrow, and then this some sort of logic, it actually ended up converting my code into a function. So it's an anonymous function with the parameter x going into the function, and then my custom logic, which is of course going to return some stuff. So you can define functions in JavaScript like this. You can actually say you can actually okay so you can actually wrap this up inside of curly braces, and it'll work. The behavior will actually not change, but when you end up wrapping your logic inside curly braces, you should actually use the return keyword, because then you'll have to explicitly assign the return type. One interesting part which TypeScript addresses with this shorthand notation, or you can say short method calling, is called context fixing. So they've actually fixed context, which which we've normally seen in nested functions. So for that, I'll just go and grab some code, grab some example code, and just paste it here. Okay, so let me just quickly comment this out. Actually, uncomment it. Yeah. So let's say I have this variable, or you can say, my bad. Actually, you have this object called alert me. It has some attributes or properties. It has a sender with police, warning with evacuate value, and then it has a start method, or you can say a function which uh, actually does nothing, but it calls a set timeout on this. Inside this, we have an anonymous function, and it then pops up an alert box for us after a second with the message, with the warning message. The problem with this, actually, the obvious problem with this code is that it won't actually print the warning which is evacuate in the alert box. What it will print is this thing. Actually object window object, I guess. Yep, object window or window object, whatever it is, but you get it, we get an idea. So the thing is, why window object? Because when we are executing this code in the browser, this actually, the context of this anonymous function is the window object. So when you say this, it actually tries to find the property warning on the window object, which is obviously not present, and that is when you get that error. So the obvious way to fix this in JavaScript when you're writing JavaScript code is, so this is how everybody does this. You can say var underscore this, or some people underscore this, or some people like to call it that, which is also very cool. So you try and preserve this of this fun. Actually, there are too many thises now, so just pay a lot of attention when I'm saying this and this. Yeah. So actually, so as soon as I enter this method, I preserve this, which points to this object alert me, and save into my local variable underscore this. Now when I go ahead and call this call this anonymous, and when my anonymous function gets called, I actually go and say do this. Now you use this underscore this, which is pointing to alert me, and then you try to find that attribute or property on that object which is warning. Now you'll get that evacuate message in the alert box after a second. So this is a workaround we always do when we're working with anonymous functions in JavaScript. Luckily for us, TypeScript has addressed this problem in the latest 1.5 release. And so the way you do it is this: use the shorthand notation of calling a function of anonymous function. You'll use this fat arrow, which will actually define a function, and then you will say alert and alert this dot warning. So what I expect this to do is it to search on this, which is actually pointing to alert me. So this is new in JavaScript. This is the addition here, that you don't have to preserve this of the calling object, and so this will actually give me the correct result. But how did TypeScript do this? So to actually check how that did, we have to compile this code. And when I compile this code, I actually come to this section. I have everything, and this is exactly doing what I did, what I or anybody would do in normal JavaScript. So this is under the hood. This is trying to cover what all problems we had in JavaScript. So all these workarounds it'll figure for you, and then as you can see, an anonymous function with an alert using underscore this variable. So it exactly does what we are used to doing, but in a more elegant way. In the next tutorial, I'll be covering interfaces. So do not forget to subscribe us, as you don't want to miss all the cool stuff in TypeScript. Thanks guys. Thanks for watching. Bye bye.